All right, this is the lecture video for day 2, which is Wednesday, September 9th. Hopefully you're watching this before Wednesday, because in class on Wednesday you should be meeting with your groups and discussing this material. So first thing on the docket for Wednesday is to get to know your groups. So spend 5 or 10 minutes just chatting, getting to know each other. And then after that, the group leader for the day, so now remember you're supposed to have a rotating group leader, but Wednesday's group leader should give a very brief summary of what we're about to talk about in this lecture video and include an example of your own. Now in the future, the group leader may have extra tasks, but for now, we're keeping it simple. Okay, so today we are talking about, this is our first lecture in statistics. And so the question is, what is statistics? And my favorite definition is that it's the art of distilling meaning from data. So the general idea is that if we have a bunch of information about the real world, a whole bunch of data points, then ideally we can make some sort of conclusion. We can get some information out of that data set and apply it to something. So that's the goal of statistics. It's this procedure, it's this framework for getting meaning from some data set. Okay, so bigger picture of the course, that's what we're talking about. This process, this procedure of getting this meaning. However, for the first couple weeks, we're really going to be focusing on the data itself. We're going to be talking about what data looks like, how we can represent it, maybe where it comes from. So we're going to talk about experimental design, as in what types of surveys or data collection we can do. And then once we've done a lot of that, we're going to then talk about this procedure of getting some sort of meaning from a data set. All right. I'd like to not throw too many definitions at you because nothing makes a math or stat lecture more boring than just a whole bunch of definitions. But the one that we're going to start off with is that a statistic is a numerical summary of data. So for example, if I had a collection of people's ages, so let's say one of the questions that I had asked on the class survey that I sent out was, how old are you? Then I might have a collection of ages, and I can take that data set, that list of 50 ages, and find some numerical summary for it. And there's a lot of options. We're going to talk about all the different types of things we can calculate, but the first and probably most obvious one is to find the average age. Right, so then the average age is a numerical summary of this data set. This average is a statistic. So the main point I want to make with this is that data needs context. So for example, if my data set looked like just a list of numbers, 18, 19, 18, 20, 21, or 20, 20, 21, 18, etc., then if it's just a list of numbers, we don't know what it is. So data isn't just the information, the data points itself, it's also the story behind it. So we obviously need to know what it is we're talking about. So in this case, maybe these are blackjack scores, but in reality, these are ages of students in the class. So the book really likes to ask the W questions: who, what, when, where, why, how. And that is sort of a silly exercise to go through, but it does put us in the right framework of thinking about a data set from the standpoint of asking, what is the point of all of this? So maybe if the what is ages, if the who, let's say are Stat 11 students, so who, what, when, maybe this was taken in fall of 2020. Let's say how with a Google form survey. So we're going to talk a lot in a little bit about where this data comes from. So experimental design is talking about what the source for, or what types of surveys we can run, and really paying attention to the data collection format. So who, what, when, where. Maybe this is at SWAT or remotely. And why is actually sort of sneakily one of the really important questions to ask. Right? We want to know what the point of this whole data gathering is. And in my little silly example here, I don't really know why we're paying attention to the students, the ages of students in Stat 11, but maybe we have a hunch that people take intro stats when they're younger versus maybe they take intro philosophy when they're older, or some hypothesis like that. So maybe this is part of a study on ages of on class ages. I don't really know what that means, but it's important to keep in mind why we're talking about what we're talking about, because that can often give us some insight into what the motivation of the whole question is. Okay, so there are a lot of different types of variables, different types of data that you can talk about, but there's one main distinction that we're going to make, and that is the difference between categorical and quantitative variables. So we're going to say that a quantitative variable measures numerical values. All right, so some examples of this are things like age, or maybe shoe size, or distance, or speed, or temperature, or these types of things. So these are things that inherently have some sort of number associated to it. And I want to be careful, we're going to talk in a minute about why it isn't just, does it have a number, but in essence, what we're asking is, all right, it's a quantitative variable if at its core, it's really talking about numbers. We're talking about measuring something. We're talking about how many of something there are. So these things often have units. So either units or just a count of something. If say we care, how many students are in each of the different classes at Swarthmore, that would still be a quantitative variable, even though the units, well, I suppose then the units are number of people, but number of blank counts as a unit. So quantitative variables typically have units, and they typically support what I like to call doing math. And so what I mean by that is you typically can add or multiply or take averages of or do calculations on the values themselves. You can find the average temperature. You can find the sum of all of the ages if you want to do that. You can do math on quantitative variables. Okay, so the contrast here are categorical variables, which we're going to say are variables that specify a group or category for the individual to be in. So let's just start off with a few examples. Maybe the example is your favorite ice cream flavor. Or maybe it's what class year you're in. All right, so it's anything that what matters is which of a few, typically, several, 2 to 10 categories do you fall into. It's called a categorical variable because what matters is which category are you in. Okay, so we've got a few examples here, and the reason that we can't necessarily say that, oh, it's quantitative if it has numbers, is because what really matters with a lot of these is how we're treating it. If we take any quantitative variable, we can treat it like a categorical variable by putting it in bins. So age, is some numbers associated with your age. We can find your average age, etc. But if instead of talking about the age itself, what we were talking about is which age group. So for example, maybe we mean 0 to 17, 18 to 30, 30 to 50, and 50 plus, right? So we now have 4 bins, four categories. And when we talk about age, we're saying, all right, you fall into one of these 4 groups, right? So now all of a sudden we've taken a quantitative variable and we've turned it into a categorical variable. And we can really do this with just about any quantitative variable. And so what really matters is what our context is, right? The reason that we care about this difference between categorical and quantitative variables is that we're going to treat them differently throughout this course. So today we're talking about how we can display data. Well, the different types of data displays that are available really depend on which type of variable we're talking about. When we start talking about inference in the future, we're going to have drastically different approaches, or slightly different approaches, depending on which type of variable we're working with. So it's important to make the distinction between categorical and quantitative, but it's also worth pointing out that the lines get a little blurred, and especially when it comes to things like color. So is color a categorical or quantitative variable? Well, it really matters how we keep track of it, right? If we just said, all right, we got the blues and the reds and the greens, then that's definitely quantitative. Sorry, that's definitely categorical. But maybe we assign some number to the hue or to the various attributes of the color. Well, then all of a sudden maybe it's quantitative. So the underlying point, the point that I'm really trying to make here is that categorical versus quantitative really is in the eye of whoever is working with this data. So if you decide that you want to make a certain thing categorical, then great, you just want to be consistent moving forward. It's worth pointing out that while quantitative variables can be put in a categorical variable framework, you can't always go the other way. It's often a special case like color where you're able to take a categorical variable and make it number-based. So just to be aware of that. The last thing that we're going to talk about today is how to display categorical data. So we're going to put off quantitative data for next time. So categorical variables can typically be displayed, can be shown either using pie charts, bar charts, or tables. So I certainly believe that most of you have seen these before, but just so we have it, here is a pie chart. We might be able to say that the area of a region corresponds to the proportion of that given that's represented by that group. So one important property that pie charts have is that they respect the area principle. In other words, the area of a certain region corresponds to how much of our sample falls in that category. Okay, nothing shocking about pie charts. Bar charts, same deal. Hopefully you've seen these before. Here we have the number of people in the various ticket classes on the Titanic, and we can see, all right, we can compare how many are in which group. So for this type of data, either a pie chart or a bar chart can get our point across. Typically we like bar charts, but there are times and places for both. Okay, so I mentioned the area principle. Oh, we're going to come back to tables in a second. The area principle is really useful for being able to look at the data and to look at this pie chart or bar chart and getting a sense of relative size. A couple things to not do. 3D graphs are very rarely going to be beneficial. So here we have a graph where if we were looking from the top down, maybe we could see that the green portion represented 40%, whereas the yellow portion only represented 30%. but because we have a 3D graph in our perspective, maybe is making it look like the yellow region is bigger than the green region, which it really shouldn't. So 3D graphs can often lead towards misleading data. Another place that we might see that the area principle, so the idea that the area represents the relative amounts in each category, might not work, is if we try to use some sort of fancy graphic. So this was from a Gizmodo magazine talking about how the new iPad has more battery life, and the point is that it had 70% more battery. So if we had axes here, maybe the increase in total battery life was an increase by 70%. However, because the graphs are of these three-dimensional pictures of batteries, you get the impression that the image on the right is much, much bigger than the image on the left. And that's because it conjures up this idea of a three-dimensional object. So part of the spiel is that 3D is often bad. Another part is really just to pay attention to what the area means. You want the width to be the same unless you're trying to specifically illustrate something. Okay, so the last way of displaying categorical variables that we want to talk about are tables, and we're going to use tables a lot, namely because it's a way of writing down, it gets all the information across, it's concise. Typically you have to look at it a little bit longer to be able to decipher what's going on, which is why sometimes rather than total numbers, you'll have percentages. But nothing should be new in this portion. I just wanted to run through this just to make sure we're all on the same page.